Alright, welcome to an AQA AS Chemistry video on elimination reactions. So, the last video I talked about the reaction with the nucleophilic or substitution reactions in general, and one of them was nucleophilic substitution, and one of the ions that we used were hydroxide ions. So, generally we're talking about halogen alkanes and then hydroxide ions. However, when halogen alkanes is reacted with hydroxide ions, an alcohol is formed via nucleophilic substitution. However, another reaction can occur, and that's called the elimination reaction. That usually produces, well, doesn't usually produce, it produces alkenes, and is generally regarded as a dehydration because you're removing water. So how does it work? So I'll go through the mechanism. So you get your hydroxide ion here. So let's label it as it is. That's your alpha carbon because that's the one that's next to your halogen, that's bonded to your halogen. This would be your beta carbon because it's the one that's adjacent to the carbon that's bonded to the halogen. So now when you have your hydroxide ion, it's not going to be bonded to, it's not going to go to your partial positive carbon atom. Instead, it's actually going to go to your hydrogen atom. So in this case, this particular hydrogen atom here, so it's always going from the bonding pair. Don't never draw it from here, always from the bonding pair to your from your bonding pair to your electrophile. In this case, the hydrogen would be the electrophile here. When that happens now, this bonding, this isn't gaining an electron when it comes, it's just breaking this bond, and it's already negatively charged here, so it's attracting positive charge. This is pretty much acting as a H+ really, because its bonding pair is maintained within the chloroethane, the chloroethane, the one chloroethane. So what happens is this bonding pair, it can't just be free like that. It needs to, in order to make it more stable, it forms a double bond here. The problem that you now have is that you have 1, 2, 3, and 4. So 1, 2, 3, 4, and 5. You can't have 5 bonds. What's the best leaving group? Not the hydrogens. This polar bond here would be broken. So you get that essentially, and then that double bond is very strong, so it doesn't want to break. Those two hydrogens aren't really polar enough. This is the most polar bonds, the best leaving group. And so this is actually a reversible reaction now. So I can go to the next part of it. Say this is a reversible reaction. Hence you do it under reflux, because to get to your final product, because you know there's only one final product, so that's what you want. This is a reversible. You can have dehydration, which is the removal of water, hence you're forming water, or hydration is using water. So in this case, we're removing water. I guess technically water is being formed in this. Really, we're not using water. This is your product. Obviously, you have a water because you've formed water, and you have a chloride ion, spectator ion, really. And that's it. If you look at the mark scheme for some of these examples, they'll show you they say, and mark for doing this part here, just putting a minus and representing the lone pair of electrons. Another mark for the arrow, another mark for this arrow here, another, and then you probably get a mark for showing this example at some point in time, and then you probably get a mark for, and you get a mark for that one there, definitely. And that's how they mark your papers. Elimination. So hydroxide ions are nucleophiles, but they're also basic. Because obviously hydroxide ions, OH minuses, they can neutrify acids by reacting with H+ to form water, one of the properties of bases are that they can neutralize acids. So it's a basic, hydroxide ions are nucleophiles, but they're also at the same time bases. And they can take a proton off a halogen or alkane if the adjacent carbon has protons on them. And this results in the formation of an alkene. Now, you probably was thinking sort of like, how can I determine if an examiner tells me, or if I look at an exam and they say, here's a hydroxide ion, or like, yeah, here's a hydroxide ion, they don't say it like this, probably a word in a better way, but for the sake of just the fact I'm explaining, I'll say, here's a hydroxide ion, here's a halogen alkane, draw out the mechanism. How can I determine whether it's nucleophilic substitution or an elimination reaction? And they make it very obvious in the test by saying one or two things. I say one of the ways to determine whether or not you're having elimination or a nucleophilic substitution is the conditions of the reaction. The conditions of the reaction determine what reaction pathway the reaction would take. And there are two ways. So there are two ways hydroxide ions can react with halogen alkanes, either by elimination to produce an alkene or substitution to produce an alcohol. Both are very possible, equal probability, but to promote elimination reaction, the following conditions must be met. You need to have used an ethanol as a solvent rather than water, and that's generally given as ethanolic conditions. They'll say hot, and then the other one is heat under reflux, i.e. 70 degrees Celsius. This part isn't really needed, but they'll usually say it's hot. Oh, they'll usually say that it's, let me put it down. This part here, highlight that part there. So it's usually hot and ethanolic and done under reflux. The reflux part is usually not seen as much, but I think it is important. It's saying it's under reflux, because there's only going to be one reaction forming, so there's only going to be one product forming in most of these cases. And even if you did get another example, which I could show, I'll show the example anyway. You're generally going to get one major protein. Like for this example, you're only going to get one product. But there are examples where, for example, the beta carbon, you can have more than one beta carbon. In this case, the beta carbon is just this one because there's no other carbons available. But beta carbon is any carbon that's adjacent to the carbon that's bonded to the halogen. So. And then because of that, you have to look at the carbocations that are being formed, or which ones are stronger, which one's going to be more stronger. So, will you form a carbocation? I guess it's just be the one that's more stable. I don't think would you form a carbocation here? It's just the one that's more stable. I'll probably need to see if I can just draw an example to show what I mean, but. Yeah, I'll just do this example here. But the main part you need to understand is when you're looking at these exams, you can just the main part saying, they told me to do this and this and this, but then the conditions are hot, ethanolic, reflux. This is an elimination reaction. That's what you need to mostly focus on, but forget. Would this make a difference? Literally just going with the flow right now. I'm just trying to see whether or not you get a major or minor product in these reactions. I think you would, because that, if I'm wrong, then you can just tell me in the comments if I'm wrong. But from what I'm seeing here, it's more like this is more likely to go to here because this is a secondary carbocation that's going to get formed. Yeah, you must form a carbocation, surely, you know, right? It's a secondary, that's less stable. Yeah, that's less stable. They're both beta carbons, betas, and then that's the alpha, obviously. Your major product is most likely going to be this. Now, if I'm wrong, comment me, but from what I've been taught, this is the most likely product. You'll get a major and a minor product in your reaction. This is your major product. Your minor product would be that's definitely more stable than this. But the reason for it being that usually when you're talking about carbocation, that's secondary carbocation, and a primary carbocation that gets formed here. I don't know. I really should know this by now, but I'm gonna look up that part actually.